Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of the Level Up Hour here on OpenShift TV. I am Chris Short, host of OpenShift TV, and I'm joined by two other people, which you can't see right now, sadly. They're in a little box off to the side, so I'm going to turn around and fix that. But I will let the illustrious Langdon White introduce himself while I'm fixing that real quick.
So hopefully y'all can hear me, even if you can't see me. And, in the grand scheme of things, isn't that better? So I'm Langdon White. We're doing the Level Up Hour, and we'll talk a little bit about the show in general. But we have a special guest today, Matt Micene. Matt, do you want to introduce yourself real quick?
Sure. Matt Micene. So I am, I think we settled on technologist in the RHEL business unit. I've done a bunch of different things for the RHEL BU. But
I struggled with your intro on the show last week of like, I think this is his job title.
It's the joy of not having an official job title since I started doing research for our market intelligence team, focusing on like technology things. So I think that makes me a technologist. I don't actually know what other people think I do. So yeah, I look at technologies and emerging technologies and how they might come to market and how they might impact Linux things and other stuff.
Well, title or no, I think of you as a technologist. So there's that. So, all right. So kind of getting right into it. Let me throw up the slides because it's not a online presentation of any kind without slides. So let's see.
It's funny. There's like a no slide kind of preference for people these days.
Oh, but yeah, totally.
We use them just as like props, right? Like,
right.
Like totally like this should just kind of be floating somewhere. But
well, I do use, even when I'm giving like presentations, like, kind of formal talks, whatever, I really do use I think it's generally referred to as like the Y Combinator style of slides now, where it's basically just like a big image and maybe a couple of keywords, and then talk to it. And people are always like, can I have the slides for the talk afterwards? And I'm like, sure.
Why?
But they're worthless. Like,
it's just a bunch of pictures.
Right. So I have actually on occasion, and I actually do recommend this, is like, if you're really like into the topic or whatever, do two sets. Do a set of slides that you're going to present with and a set of slides that actually can stand on their own.
Wow,
and then when somebody asks for the slides, give them the second set or give them both, but yeah, because you don't want to present slides with 87 different bullets.
No.
So on that note, go ahead, Matt, sorry.
Oh, the quick hint for that, because it sounds like a lot of work, is once you've made your Kawasaki slides, not Y Combinator. He was around long before
Y
Combinator.
That's
true. Yeah.
He literally wrote the books on this. Take your speaker notes and literally make slides out of your speaker notes. That's the easiest way to get that second set of slides, because that's usually what you want people they want to be able to refer back to, is what you said. And most of us are usually pretty good about that data being there, even if it's not actually things we say out loud.
Right. Yeah, that's true.
And generally speaking, I take those speaker notes and either they were a blog post before it became a talk, or they turn into a blog post or some kind of article somewhere. That like reusing that content in multiple venues is totally acceptable, and often like a great way to bring more eyes to it.
Yeah, no, I definitely hear that. Like there's something to be said for having kind of almost like a series around a particular topic. If anybody wants to get into the speaking thing. So hello to, let's see, we have Det Conan Kudo, who tends to change his name a lot. And someone refers to Matt as a futurologist. I assume they're referring to Matt.
Yes, they are referring to Matt there.
Yeah. All right, so the Level Up Hour. This is what we do. Okay, so about the show. So this show is about kind of like I hesitate to say like introduction to containers. It's not that as much as trying to show why containers are kind of useful all the time, particularly for people who it may not occur to them that they might want to use containers. So like containers are very much focused, or like all the advertising and everything else or marketing is around developers, right? To throw back to Microsoft a number of years ago. But in fact, they're quite useful in lots of other situations. And so the things we've covered on the show are like making a tools container that you can use in your data center, or talking about the toolbox container that was developed by some Red Hatters for Fedora, or like deploying like your own Nextcloud is what we've done the past few episodes. And today, what we're going to talk about is doing data science with containers, or arguably science in general, because one of the things that you want in science is capital R reproducibility.
Yes.
Because you want your peers to be able to review your stuff. So much like, quality assurance in the software world, you need to be able to replicate something somewhere else so that you can prove that it wasn't some anomaly of your environment that that made your science turn out the way you wanted it to, or the way it did even. So follow us on Twitter. I'm Langdon with a 1, and Chris Short is Chris Short, and Matt Micene is Cleverbeard, even though I didn't put him on the slide. I probably should have. You can join us to chat on our Discord. And we're kind of there all the time. But that's one channel also to participate in the live stream show as well. With the magic of Restream, most of the time it's replicated across all the different channels.
Most of the time, yes. Today it's working very well.
Is it? Is it?
Yes.
Good. Awesome.
Yeah.
All right. So I screwed up my intro and did the intro of today versus the intro of the show first. But whatever. Yeah. So today is containers, data science, and replication. Last week I hadn't finished the show notes in time, so here are the show notes for both episodes. Last week's episode
right now,
and the episode before that. So obviously, if you just go to episodes, you can find them all. I even updated.
That's what I have bookmarked. To be honest with you.
Oh yeah, right. So there's that, and I think that's it for slides, because if we move on, we will be giving away internet points.
Yeah, I'm gonna need to wait on that for a minute.
Oh yeah. I mean, those are a big deal. So I'm going to stop sharing and kind of not hand it over, but kind of hand it over to Matt and kind of say, can you give us a little background on like how containers can kind of help us in this problem space, or even why you got into this problem space?
Yeah, I think your intro to replication is probably the good place to start, right? Is like what's one of the fundamental problems in that big R replication, big R reproducibility that we hit in science that we don't necessarily hit in sort of typical application development. So let's start there, right? If we've got an app we built and we're looking to replicate it, like either we're typically looking at like Kubernetes replica sets, like I need 47 copies of this particular binary and it's configs to spin up so that I can handle load or something along those lines. Or at the other end, you're talking about minor variations that don't really matter. Like if we're talking about compiling code, minor differences in environment, as long as the application is the same, like we don't really care that they're not 100% binary exact, right? Like,
yeah, and you don't need that shot of match right. Most of the time. Yeah,
exactly. We're looking for outcomes, and in the science world, and I think a lot of people got exposure to this year in particular. There's been a lot of news about whether or not X study or Y study is reproducible and provable, and is the data there, and what does the math really say?
Say for like a vaccine, maybe.
Yeah, exactly. There's been a strange thing happening for the past 9 months that right. Suddenly this is sort of mainstream news, quite literally, and so it's a little bit easier to talk about, say, today than it was 3 years ago at DevConf, because this wasn't on everyone's tongue about was this study reproducible.
Right.
So typically what's like, you go back, I don't know, 2010 probably, if you people who publish scientific studies, they're usually papers, right? Literally PDFs with, you did math, you have tables, you probably write out your generic formula in, actual mathematical symbols, and there's descriptions maybe of how they were used. And then your final, like, here's the fancy table that shows me my log graph of whatever was being studied. And that sort of was it, right? If somebody wanted to reproduce that, they had to hopefully read all of your paper, understand it, figure out your algorithm actually from your formula, and then hopefully you maybe Langdon put the data somewhere that might be shareable, but hopefully it wasn't proprietary under some sort of NDA from a big pharma company. So like there's all sorts of issues with, like, once you publish the paper, how do you actually go about fact checking it? Like, how do you do it, right? If I have your code, on the other hand, right, there's a big step there in what I can do to check your assumptions and how you got from point A to point B. So I said, I think it's 2010, maybe 2011, there starts this conversation about what they're calling executable papers.
Mm-hmm. Oh, that's interesting. I
Um,
haven't heard this before.
yeah, so it sort of follows along the lines, if you're familiar with Jupyter notebooks.
Yeah.
Right. So Project Jupyter is probably 15 years old, I think.
Yeah.
And that notebook concept, right, it combines the ability to write prose and then show code examples and have those examples execute and then have the results, right, in a nice little web page. Based on some of that work and some other things that were going on in science at the time, this executable research paper starts popping up in various different places. And the idea is we have a lot of science that's backed by a lot of math that carries a lot of data. The best way to get to a state where it's easy to peer review these things is publish it all together in one format so that somebody can walk along and look at your code and go, oh, you know what, that algorithm looks like it replicates this formula, but it doesn't because you did this wrong, or because we know that there's a flaw here. And also your data is there, so you can just like, oh, that table, click, yep, that table actually, that code with that data reproduces that table. It wasn't, a publishing error.
So actually, it kind of, at least for me, raises a question that I often have about this, and you kind of alluded to it a little bit.
Mhm.
But let's say the data is, available, like it's not proprietary or whatever. Is there any sort of best practices emerging about sharing that data without, basically mailing me a hard drive because it's, terabytes of content, and because that's often a problem, both in this kind of science replication area, but also in kind of just general software development, especially data science?
Yeah, I don't know that there's any singular answer to that yet, because that's the other side of the issue, right? Is if we start talking about like containers and go back to that example, most folks they only care about the binary and the config files, right?
Mhm.
So that push to, I want my 6 meg Go container that does one thing and that's all it does.
Mhm.
The ones built around data science and other science support without the data, right? We're talking about fairly complex Python environments, R environments, just from getting the libraries in place, right? So there's a lot of different ways that people have gone about, like, okay, we'll jam it in the container. That way we know it's versioned and replicated, right? Because
Mhm.
that's an important part. Other folks have looked at large file support in uh, like online version control systems, like using LFA and GitHub or something along those lines.
Right. Right.
There's even specialty sorts of hubs, if you will, that like Jupyter Hub. And there's 2 others that I cannot think of the name of right now that are designed to sort of allow you to publish your things there and then let other people pull it down. Binder sort of does that with Jupyter notebooks and data, and then allows people to get access to them. So I don't think that one's solved yet, because it's the typical data issue, right? The
Right.
biggest problem with any data, like, it doesn't matter what you're talking about, is inertia.
Right. Right.
We've got this
Yeah.
giant, massive data. How do I move it?
that data set and its whole mass, if you will, has its own gravity, and this is a problem that I've tried to address in my past and had some success, but I mean, really, it's a hard problem to solve.
Well, this is one of the things that I find really interesting. So the former CTO of Joyent, who I can never remember his name, he's now at
Brian Cantrell.
There you go.
Yeah. Has a bunch of interesting like articles about basically moving your compute to the data rather than moving data to compute. You know,
Well, that
because
makes more sense. Yeah.
It does, but it's not how we do software 99% of the time. And it does work a lot better if you can just set that petabyte of data somewhere, right, and then move the compute to it. And that's I think a really kind of much more interesting model, and I'd really like to see, you know, kind of software development kind of adopt that in general. But so kind of going back to you know, kind of this replication in the science space, you know, typically scientists are not programmers, or not, you know, not trained as programmers. So is there infrastructure in place that helps them in a sense, or provides frameworks, or, you know, whatever? I mean, R basically exists in some senses because of science, but that's pretty low level for the kind of frameworks or support we normally look for to help non-programmers program in a sense.
Right. Yeah, because the folks who are doing this level of science, they will very well be R experts or Python experts, but they're not Python module experts, right? And as an amateur, I am not going to ever call myself a professional in working with natural language programming, which is like the things I'm currently looking at and poking at. I probably have 5 or 6 projects that vary by 1 or 2 libraries, and I'm trying out a different technique that I learned online, or trying to thief something from someone's blog post to try to learn something. So they're almost identical, but for, you know, one library, one set of modules that I need, and I probably have 6 or 7 then different virtual environments in Python. And this happened to me just this week. I went to pick one up and move it, and I'm using pipenv, and I've got a piplock file, and I dump it to a requirements.txt, and I pull it over and like pip install. Like that should work, right? It's Python. Doesn't work. Somehow something got version locked to a version that doesn't work with like I'm using Python 3.6. It picks up a version that wants Python 3.8. Like, how does that happen?
Right.
And I love Python. I use it all the time. Like, how does it happen to me? It happened to some poor other developer, like scientist, who's trying to figure out, let alone, do I use Conda? Do I use Upstream? Do I use, you know, the distribution version? Packaged.
Yeah.
Like, there's so many different options. And then you layer on, well, do I use a notebook, and then which notebook, and then do I use R, and which, like the distribution issues of the languages alone.
Yeah.
So there are folks out there that are looking at, like, okay, like Jupyter does put out containers that have, this is the kitchen sink for data science.
Yeah.
And it's good. It works.
Yeah, I think I've actually used that before. Yeah, the one of the things actually that's super useful about the Python community in particular is that they're friendly in a sense with their downstream distributions as much as possible. So unlike a lot of the languages, you know, when they are kind of designing the packaging format, they're actually intentionally making choices that make it easier to distribute in a Linux distribution. So, you know, unlike a lot of languages, like this is one of the things that people don't really understand is like, why can't we get an RPM, say, from, you know, a Python module or a Ruby module or whatever? And a lot of it has to do with like, you know, kind of just automatically, I mean, but a lot of it actually has to do with the metadata being missing, and stupid stuff like the license on that particular module. An RPM requires the license information, and if it's not on that Ruby module, which at least that was the classic example, I don't know if that's still true, but they don't distribute it in gems, so you have to manually go and look it up. And you know, I think NPM had the same problem. Whereas Python has been progressive, like every time there's a change to something like RPM or whatever, they're trying to make sure that all the metadata exists that you might require as a downstream distribution to automate that distribution as much as possible, which is super nice. So JP Date actually brings up a really good point of, you know, isn't pip how you install stuff with Python akin to Yum or DNF? Well, that's the whole problem, is that they're not akin. they're two different solutions to a similar or the same problem that do not interact with each other. And this is actually something that's been looked at for a long time in DNF, for example. Can we make DNF essentially a wrapper around all the other packaging tools, right? So apparently the only way that you can get your like true like my new programming language creds or whatever is write a package manager. So so every single language has a different one. Lots of now we have different ones on different platforms as well. Like I mean there's at least 2 or 3 now for Windows. There's at least 2 for Mac OS as well. Then we have all the BSD ones, then we have, or BSD has ones, and then we have, Debian, and we have, kind of the RHEL and its friends with RPM. None of these work together. None of these work in the same way. Their dependency management, their dependency solving are all different. Even though this is actually, going back to science, this is actually a well understood problem that has been solved with math and proved. But instead of just saying, hey, let's have the universal installer, apparently it's cool to write your own package manager.
Well, yeah, and that was actually the solution to my problem was I was actually switching between 2 different Python package managers, really, because I was using pipenv in one environment, which not only deals with pip, but also sets up the virtual environment.
Yep.
And raw pip in the container, because I was like, well, I don't need pipenv for all this. It's just a container.
Right.
And somehow in the pip file lock for pipenv, that's where it inserted this weird version string, which I haven't gone back to look at that actual virtual environment. But the solution was let pip be smarter than me,
right,
and do the right thing. And now it works. I was like, okay, we'll just remove the version requirement that locked on that file in the requirements text, and lo and behold, pip is designed to solve for this and solves for it correctly, and I have a working environment in a container. So yeah.
Well, I mean, and that's often the big problem, right? As long like if you're not mixing and matching, it often works. So you'll have Python developers, for example, who will not install anything coming from anywhere besides upstream pip. The downside to that is that if you kind of going back to that version locking problem, this is one of those really arguable positions. It's like, and one of the things actually we were trying to solve actually with modularity and app streams is I want guarantees that the version I worked with will still work. So in other words, so I go and version lock everything. You can do this in basically every package manager somehow. You can do it with DNF. You can do it with apt-get. But the problem with version locking is you get exactly what you version lock to. Well, that means no security updates. That means no patches for like security bugs or whatever, or even just bugs in general that won't necessarily or shouldn't impact your running application. This was my classic example of this is PHP. Back in the day, all the Linux distributions upgraded to 5.3, I think it was.
Yeah.
And if you did that, WordPress and Drupal wouldn't run because they only worked with 5.2. And so you also have different like kind of rules depending on the language, depending on the environment, about what things will be backwards compatible, et cetera, et cetera. So that was a bit of a digression into one of my pet peeves of package managers.
But it's actually an interesting way to bring it back, though, too, is because the replication that we talked about and the reproducibility that we talked about earlier, since we're not talking about long-running exposed attack surface style web applications, it's exactly that level of version locking that we need to make sure we have available, so that, I don't know, if I'm trying to reproduce an experiment that Chris built, and he likes the OpenBLAS linear algebra setup for SciPy and NumPy, but I prefer Atlas, that when I take his code and his data, right, we can't just stop at code and data, because we don't want version mismatches or developer choice in what's my implementation to actually impact that outcome, right? So these things really do need to be like super specifically version locked. And then to complicate it further, we go back to like our title of data science. Like, let's look at machine learning and artificial intelligence packages, right? The data science one that we just talked about from Jupyter Hub, that's, I'm going to call that like traditional data science. It's mostly math libraries and scikit-learn and those sorts of things. It's got some machine learning, but it's not PyFlow or TensorFlow or some of these larger abstractions around deep learning and the rest. So once you start trying to coordinate 15 different sets of requirements and libraries and modules and their accompanying data sets and corpuses and lexicons and like not the experiment data, just the things it needs to run to know that, I shouldn't count the word the every time it shows up as significant.
Right.
And what is a stop word, right?
Yeah, exactly. Yeah, this is stop words. I was trying not to use the stop word jargon. Thank you, Langdon, but yes.
Sorry.
So
I did a bunch of data science in this space. So
yeah, so a bunch of our data scientists actually at Red Hat had been working on this problem so we've got a center of excellence built around AI, and they've been working on this thing that is called the Open Data Hub. Yep. And its entire purpose in life is to solve all of these issues for you by letting them take care of all of those problems and giving you a button in an operator that you can just push the button and get a data science environment. And it's always going to be the same, and you can control how it upgrades and what capabilities it has are always going to be identical. And no matter who runs it, where they run it, they just need to push the button, get their environment, and then attach it to some data and start going, right? So there's like the one end is there's one-off onesie twosie people building, here's a catalog of containers of 6 different options, and then there's here's this all singing, all dancing, orchestrated massive beast of an operator that can do magic for you.
Well, and replicable magic in a sense.
Yes, identical magic.
Right. Yeah. Interesting. I actually didn't realize that was one of the kind of goals of Open Data Hub. But that is definitely interesting. One of the things I think, kind of my own experience that we're also seeing is universities kind of starting to recognize this problem and collaborating more in order to with other universities in order to try to resolve some of these challenges. So like a project, Matt, I think you're familiar with, but one that Red Hat's involved in is the Massachusetts Open Cloud, which is, I just blanked on the word. But association, a group, a thing, collaboration. It's actually, so a collaboration of like, I think it's like Boston University, MIT, I think Harvard's involved, like a whole bunch of universities. And they basically put a whole bunch of hardware in a data center, and what's interesting is the project itself is its own science, as well as supporting other people's science. So what they're trying to do is make an open stack or some sort of basically public cloud that you can share hardware into and get hardware out of when you need it. And so, the problem with your typical cloud, right, is that you have to go buy it kind of on demand. And if you have existing assets, especially, big iron assets, there's no way to kind of have them participate, or when they're slow, share them with others. And so that's one of the problems that organization's trying to solve. But while they're solving that, they're also offering to, they primarily seem to be focused on like biology research for whatever reason. And so there's a bunch of biologists who are doing a lot of, kind of research work, big data type work on their platform while they're moving bits around, which I think is kind of entertaining.
So there's a question here from NL Hackham, as we've decided to call him. So what's the difference? So what's the science of data science if the outcome of the same algorithm can vary with the version of Python you're using? Shouldn't 2 + 2 always equal 4?
Yes, 2 + 2 should always equal 4 for large enough quantities of 4. Or small enough quantities of 2. But so usually it's not
It's not simple
so much
math.
yeah
Right?
it's not so much that the math varies, it's that the implementation of the algorithm. So we get into the nitpicking details between the formula and the algorithm, right? The formula is the math written on the whiteboard, and that is what it is, and the algorithm is how you implement it. And so implementation details, depending on what you're doing, and for data science it's a little bit different, because there we're looking for things like, when we talk about some of these differences, folks are typically talking about like training speeds and accuracy levels, right? So
Right.
uh, how accurate is a model over another model could be a variation in some of the math packs that they use, right? Their implementations of certain kinds of algorithms. So for data science, it's a little more not a I read your paper, I recoded your stuff, and I got a different answer, so much as it is, I took your model, I took your training data, and it wasn't as accurate as you claimed, or it took 47 times as long, so therefore that's not good because that's not what you said you did in your paper.
Well, and one of the points I would make too is like Michelle Orlanti maybe brings up in the chat, when we do math on computers, we make trade-offs, especially when those numbers are really, really big. And rounding errors, and so their example, right, is 4 followed by a whole bunch of zeros and then 1. Rounding errors are a big deal. Where you take the rounding error pain also has an impact. Another one that comes up, which is kind of weirdly interesting, is most random number generators on a computer are not actually random. And so if you use what do they call it? Pseudo-random, totally blanked. If you use pseudo-random inputs, that can actually have an effect on your outcome, because you actually are because of the lack of randomness, you actually get some variation in the result. So like if we were doing all this work by hand, it would be very replicable. It would also take 200 or 300 years, and that's the problem, right?
Mm-hmm.
And one of the reasons I would say that there's also a big push for quantum computing in this kind of space, because quantum computing can be significantly more accurate in a very, very odd sort of way, because it can actually model the true numbers involved rather than our approximations on using a binary system kind of way down underneath. And if we weren't getting too deep into computer science, this is one of the big pushes for why quantum computing is so appealing, especially in the science world. So yeah.
Well, and I'm gonna blame Python, even though I don't specifically recall that this was the language. But on the narrow end of that, rounding error issues, I think it was Python. They switched from 2 to 3. They changed how rounding picked where it was going on simple math. So you could have something that 2 plus 2 was 4 in Python 2, but 2 plus 2 was 5 in Python 3 because it was actually
2.967, right?
It was at the rounding point where in Python 2 it would round down, and in Python 3 it would round up. So yeah, and again, I'm blaming Python, but I don't actually remember that it was Python. But I know it was a pretty common language. It was on a major version boundary like that.
Yeah,
so yeah, I mean, even on the short end, like simply a programmer's like, yeah, we now have floats, so I can round longer. Like I've got better access to 64-bit hardware, so I can round differently. And suddenly, from a major version of a language to another, it's doing math different.
Yeah. I don't like math on computers is really, really hard if you've never done kind of real math. When you're doing 2 plus 2 equals 4, it's not too big a deal. It's funny, right? Because when I was in college, and then shortly thereafter I worked in R&D, I did the math in college, and I did a lot of that stuff in computer science land, right? And then I went and worked in an R&D center for a while, and used a lot of that math or whatever. From then on, my math is counting by 1 and knowing when to stop, and that's about it, right? And so it's kind of amusing you do all this kind of really high level math, and how to implement that in software, in computer science, classes or whatever. But if you go on to be a software developer, you actually don't, generally speaking, have to do very much of this. So it's kind of roaring back with the push, with the push on data science. And so a lot of that, math is being dredged up, and all the problems with math on computers is kind of coming back. Did we have any other questions in the chat?
I mean, we've been having a general conversation about, bioinformatics, genomics, data science, that kind of thing. We talked about protein folding a little bit and the recent advancement there, kind of thing, which is awesome. If for folks that haven't heard, what was it? DeepMind has made some, quote, unprecedented progress on protein folding. And it's like, when you think about protein folding and how that can cure cancer or genetic diseases, it's, having any kind of advancement there is a big gain, especially if DeepMind can then take that and then put it into all the people that are using things like folding at home. That algorithm then gets better and can solve more problems faster, kind of deal. So, which is pretty awesome.
Protein folding is one of those ones that's super interesting for me because, do you remember there was a kid a couple of years ago, like somewhere between 12 and 18-ish, who kind of won the prize for doing the most protein folding, and
yeah.
is not a scientist per se, but has learned a ton about, kind of genomics and that kind of stuff, from kind of working with the protein folding algorithms and tools, which also reminds me of another story. When I was doing math, I did a lot of math that was not straight up computer science math because I thought it was fun. And one of the spaces is this space called tilings, which is where what kind of shapes can you put on a plane that will cover the plane completely. Yeah, well, right, exactly. This has this is a problem space that's really interesting when you're trying to coat things in material, for example, like the shuttle with tiles for heat dissipation. But this woman who was a housewife, in her 30s or 40s or something like that, discovered something like 7 of the 12 just doing them on her kitchen table when in her free time.
Right. Yeah.
Which, it's that kind of story where I really when the barrier to entry into science and math is so low, where people can just participate. I think that's really awesome.
I think that's the upside of some of these, things like Kaggle and Binder and putting these things out there in the public that are easy to grab and run on pretty much any laptop, right? So we get back to the other promise of containers, that transportability concept, right? That it's written once and I can run it anywhere, even though that's probably trademarked by Son, and I shouldn't say that out loud unless I'm talking about Java.
That's right. It wants to debug it everywhere.
I had a Java champion on yesterday. We're good.
Okay. Most of my professional system administration career is all Java scars, so I have feelings. But the idea of being able to for anyone to join in, I don't know if anyone's participated in Kaggle. It's actually built a really good community. There's a lot of people out there that as a newbie data scientist, there's a lot of other very accomplished folks who are doing these challenges to put these to do this work. And it's a very much it's a competition, but at the same time, it's, hey, I put this out there and this is my code. What do you think? And you'll get comments from very, very experienced folks saying, well, this is an interesting approach, but have you looked at XYZ, or this is off, you should check these things. So they're building communities around this sort of stuff.
Sorry,
on the other side,
I'm not familiar with Kaggle.
Kaggle with a K.
KAGGLE.com. It's all about.
Link in chat now.
Thanks.
Yeah, I know Red Hat has actually put out a couple of challenges around. I think it was one of the ones that I looked at was sentiment analysis and some in some tweets. So some of them are just community driven challenges. Others are actually businesses putting out bounties on, hey, we need an approach to do this sort of analysis on this data, and we don't have the resources to do it, that sort of thing. So it's a very interesting place to go lurk and learn. And then the other one is sort of the idea that you brought up about compute locality. I think that's sort of an old school thing in the high performance compute environment that I used to deal with from a customer standpoint, and a long time ago. And
a galaxy far away.
Far away. And that was one of the, like, I have these vague recollections, like back when we were talking to these folks about building data lakes, big data, in the Stone Ages. And the idea of having a Ceph or a Gluster cluster that you ran compute on, like, it was like, that would be amazing if you could ever figure out how to do that, because the traditional model of install an application didn't work correctly. But in a modern world, fire up a couple of containers on a data lake, like, this is a much different sort of proposition, and to be able to actually do those sorts of things in a controlled fashion without completely destroying data and nodes and all that sort of management, right? So
right,
yeah,
right. I mean, management in general of that entire kind of like platform is often the challenge. How do you, and performance too, right? I mean, with data lakes, for example, like, when you're doing software development against data lake, you're insane if you're actually hitting the data lake directly. What you're actually doing is usually building a data mart in front of the lake to basically do the initial data massage, so that when your application tries to read the content, it's been massaged in such a way that it's easier for the application to consume, so that you actually get performance numbers that are in the milliseconds versus in the minutes. Because a well-designed data lake is
that
not
like a data cache. I mean,
yeah, actually, that's what I mean.
Okay.
That's really what a data mart is.
Yeah.
It's one of those things. Like lots of things in software, there's 87 different definitions depending on who you ask.
Right.
But generally speaking, a data mart is considered sometimes a write-through cache, but often just a read-only cache of a lake. So because the way data is stored in a data lake, generally speaking, is not a good design for that data, for the applications that would consume that data. So yeah, it's kind of an interesting problem. Again, something I used to work in a long time ago. Yeah, so we did have kind of the example that we were talking about, Matt, you and I, before the show. Is it worth kind of going through that, or talking about the kind of container tool chain or deal that you had been working on?
I mean, we could. It's a little bit old and dated at this point in time. It was for a presentation I did in 2017 at DevConf in Brno.
That's still pretty new.
Well, you would think so,
Yeah.
until you go look at that contain science and realize it's ancient and doesn't build anymore, because, well, containers have moved on since I wrote it the first time. 3 years is a long time in the container space. But the idea, though, I think is along the lines of what we've been talking about, right? Is how do you build for the people who are the scientists and doing the experiments? How do you build a set of tools, or a set of toolboxes that they can use consistently without having to be experts themselves in packaging and dependency management, right? And it's the same sort of challenge that the Jupyter Hub images that we talked about are there. I'm currently poking around with VS Code because they recently dropped some support for Podman into their container remote execution plugin module extension. That's what they call them. They call them extensions.
You pick a word.
Yeah.
Yeah.
So I think, as an example, as an exemplar of like what the challenge space is, it's still a valid repo. As an actual workable example, not so much anymore. But it essentially set up the linear algebra example that I brought up earlier. Is that, if somebody wants to see how the different implementations of that are available for Python for NumPy to do linear algebra. You could easily set up two different, you set up your base container and then layer on two different new layers that set up that, and then the data scientist or the scientist can pick from those on top. And how do you maintain that stack underneath for them so that they don't have to?
Yeah, Narendav's asking what the traditional data mart would look like, Langdon. Would it be like something you would use SQL to access, no SQL,
So
GraphQL? I mean, how would you like talk to this data mart?
so it really depends on the system. As
Mhm.
I kind of responded in the chat, it has a lot to do with the design or the goal of the tool or the implementation rather
Mhm.
than the product set. You would choose the product based on the goal. So Redis is name value pairs. So very, very good if you have very disparate data, but it's kind of in that construct. So think like environment variables, but lots and lots of them. So if you have that kind of data, then Redis is a good choice. If you take what we used to call document stores that are often referred to as NoSQL databases now, like MongoDB, for example, MongoDB is really, really good if you need a big block of data based on a small piece of data. So especially if that block of data, the structure of it is not that important. So this, a great example, I was actually talking about this with my brother who works for a museum. Museum websites are good, or can be a good place for something like a Mongo, because you say, hey, I want art exhibit X, right? And you get back this whole block of images of it, curators descriptions, why it's important, the history of it, all this stuff. The individual pieces, the structure of that data is not that important. You're not going to have duplications across like the curator's comments across pieces of art, right? So there's no deduplication there. So you just kind of pull that whole block back. Whereas like a traditional SQL database is really good when the data is structured. And what I actually often recommend is people start their development of their application with something like a MongoDB when you don't know what the structure is going to be or where the structure is going to fall, and then basically migrate data into a SQL database as you understand the structure of what you're actually looking at. When you talk about a data mart, I would say, in my experience, they are traditionally SQL databases, because the lake is well structured, generally speaking. But you want to do some manipulation. So for example, most, a true, this goes back to going to computer science. When you talk about SQL, one of the things they tell you is always put it in fourth normal form, which basically reduces the duplication of data across your data set by as much as humanly possible. But that means you have a ton of different tables. So for example, your customer record might be made up of like 57 different tables, all with 5 columns each, because that's the way the data is structured and that's the way you get the most deduplication. But for a front end application who needs to display the customer profile, that's very expensive to go and query that entire 57 set of tables for that one record, really. So what you do in a data mart is actually create like a view, right, in the SQL sense, except maybe not literally implemented this way. Usually there's an old term for it. It's like an implemented view or something. But basically, where you've already crashed the 57 tables together, now you have a customer record in one table, but it has lots of duplicated data, which is fine because you're only pulling out a piece of your lake. So you're talking a gig, right, instead of 5 petabytes. And so that's kind of what the idea behind marting is. I would say, and then basically it's like, going back to the museum example, your lake might be all the different art that you have. You can actually think of a physical museum, usually something like 20% or less of the art is actually on display. Most of it is in their basement, and they rotate it through because they don't have enough physical space to show it all off at once. Same kind of idea. So like, your lake might have all of the things that you've ever heard of, any special exhibits you've ever had, things that were on loan from all these other places, et cetera, et cetera. Whereas your mart in front of that, even if the mart is now MongoDB, let's say, is just the stuff that is currently things that you're showing on the website. So that's another example. So that was, I don't know, does that answer the question? That was kind of long. It's a complicated subject.
I would assume, yeah, it's complicated. And that's as good as we're gonna get, I think.
Right. It's a space where if you play in it, it comes like it gets really clear very fast. Like the first time I tried to pull a query against a 57 table customer record, I discovered very, very fast that I wanted my response times to be not minutes, right? So yeah, so it makes it much easier once you actually participate in the space. I'm gonna digress here because it's like 10 of, and say,
yeah, we got some points to give away.
Gotta do some sweet internet points. And I will share the screen.
Mm-hmm. You want me to play screen sharing music?
That would be kind of hilarious. Really, I would think it's more similar to Jeopardy music.
No, I mean, it's copywritten, right? Like,
that's true. Yeah, that's true. But so is Happy Birthday. We use that a lot.
And so who was it that said they discovered and tried to copyright some copyright troll? Like they discovered supposedly every rhythm that you could possibly do a while back. Anyways, yeah. So I probably just violated somebody's copyright just by coming up with something in my head. Yeah.
Well, and then there was the other person who wrote a new Happy Birthday.
Yes.
It wasn't proprietary.
But then the lawsuit was won to like make Happy Birthday normal again, but everybody had moved on.
Right.
Anyways, points.
All right, so sweet internet points. For anybody who's new to the show, we award points for coming to the show or for doing a PR on our repo, or filing issues. There's actually there's an activities page on the repo itself. Let's see. Can I copy paste this from anywhere now that I'm not allowed to actually open the slides independently of the
don't know
presentation? But Netherlands Hackham 2,900 points. Narendev with 2,400 points. Noah Friction 2,300. Joe Fuzz still holding on with 1,800. And then we have a couple of people with a few episodes under their belt.
Yeah.
And JP Dade, we know you're here all the time, so why do you have no points? So yeah, the only way you can get points is by collecting them. I am trying to get the cut and pastable version.
Yeah, I was about to.
I got
pull
it.
Your slides. Okay.
And so. So collect the internet points. We think they're a fun and entertaining way to kind of say, hey, I came to the show, I'm engaged with the show. Someday, maybe we will have prizes for the internet points. At this point, we just like to give them away, and we like to say, hey, thanks Netherlands Hackham, thanks Narendev, thanks Noah, thanks Joe Fuzz, thanks JP Dade. For coming to the show, and we really appreciate your questions. We appreciate you being here, because this would not be any fun with no audience. The other thing I want to highlight again this week was some brand new people with sweet internet points, and I'm going to just destroy these. But Sakawat, maybe, Dark Owls, yeah, and then I was reading this as Madow, but maybe it's supposed to be Meadow.
Meadow, yeah,
but
that's what I read.
It should be AE, shouldn't it? Shouldn't it be MA3DOW? Or is it MEA?
I think it's MEA.
Okay, all right. So, that, however, just FYI, that is the wrong code. That is from a prior episode. I didn't realize I'd put the code on this one too. So it is not updated. So don't use that one. Use the one in the chat. That's from some other random episode, which you can go watch yourself. And if you go and watch past episodes, you can still submit for the points for future. See. So somebody in the chat
someone
actually
always
wrote out
Meadow,
and now I recognize it. I have a very hard time spelling out loud. So thanks to the new people. We hope you come back. We hope you apply for some more internet points. we have some people at the top who have been at the top for a long time. We really need them to, have some competition. There are always dark horses though, because if you fill out the form and put private in for your public name, I will not mention you in any way. And so you never know if there is a dark horse out there. Cool.
So Matt, what do you think of the sweet internet points?
I mean, internet points are always good, and hoarding is a very valid and useful thing to do, especially in the dark times of 2020. I think grabbing as many as you can and keeping them for future something like a squirrel. It's winter. We should do that. Yeah, definitely.
Yeah, so to borrow from another organization, got to catch them all. Is that what you're saying?
Sure. I was thinking, stuff them in a tree, bury them in a hole.
Yeah.
The typical dragon and squirrel things. It's weird how dragons and squirrels do the same thing. Like I don't know if anyone's noticed that before, but
that is
squirrels are basically dragons without wings.
See, I actually
that's gonna blow my dog's mind.
I live in the city, so as far as I'm concerned, squirrels are really climbing rats, right? We have flying rats, which is another word for a pigeon, et cetera. And then we have actual rats because I live in Boston. But yeah, so thanks everybody for coming. Should we wrap it up there? Do we have any other closing comments? I did have one. Sorry, I almost forgot.
Go ahead.
Which was, let me just find my notes because I have a link. Someone in the show last time asked for OpenShift kind of starter friendly options. And let me kill the sharing because I like it better when we're not sharing. And so recently we released I'm going to get the name wrong, OpenShift Developer Sandbox, I want to call it. And you can go check it out. And this will give you an OpenShift cluster for some period of time to do with as you will. So we already, as we've talked about on the show before, we have a bunch of cool things like the learn.openshift.com or try.openshift.com, which kind of give you more of a guided experience. You can also contact whoever your Red Hat representative is, and they have even more access to kind of guided content if you want to play around with OpenShift. But we just launched this developer sandbox, which I think is super cool, and you should go check it out. And because Matt's here and is part of RHEL, we will also pitch the developer program, which gives you no cost access to RHEL for many use cases. One of the things that we're actually working on is trying to update the FAQ kind of, not the T's and C's. The T's and C's are pretty good. The problem is people read the terms and conditions around the usage of RHEL in the doc, and they think that there's lots of scenarios that they can't use it, which are not actually accurate. You can actually use it in a ridiculously large number of ways and still be license compliant. So some free and, like they said, starter and free options, I think. So I just wanted to kind of share that because I think the dev sandbox literally went live this week.
Yes, the 9th.
The 9th, there you go.
Last
it's
week,
right in the URL even. So check it out. And, definitely come back for the next show where we will be talking about, what are we talking about? Oh, we're talking about the Docker, the deprecation of Docker in Kubernetes.
That's the next show?
That's supposed to be the next show, yeah.
Oh, great. All right.
That sounds like fun.
Yeah.
Well, I mean, to be honest, it was a CNCF ambassador challenge that we had to all hands on board kind of thing on Twitter one day a couple weeks ago. So yeah, that'll be fun to talk about.
Yeah. Well, so I basically want to do some kind of examples of why it probably doesn't matter. So I'm going to try to prep that for the next show. If I don't finish prepping it for the next show, then we will be doing something else. But so watch for, kind of my Twitter feed, Chris's Twitter feed, the OpenShift Twitter feed, the Red Hat Twitter feed sometimes for what, the topic of the show will be. One of the other things I'm trying to tee up is trying to get some of the data scientists who work for Red Hat to also help us with a data science show. And yes, we are taking a couple-week break. Our next show will be the January 7th or something?
6th, yeah.
6th. So yeah, so we're taking a couple weeks off because we got to get our writers to come up with more jokes and all that stuff.
Wait, you have a writer?
Yeah, don't you?
No.
I've been getting content from the whole writing team. Like,
oh, wow.
Yeah, but we got to give them a break once in a while. Yeah. So and then the other episode that I want to do soon as well is service mesh with Nextcloud. So like,
yes,
we got Nextcloud deployed into OpenShift. I want to show a bunch of the cool things we can do with service mesh without actually doing anything. Like, we're just going to check some boxes, and we're going to have all kinds of cool things like secure traffic across the application, things like being able to do traffic shaping and traffic flow and canary deployments and weird stuff like that. So my current plan basically is that on the 6th we're going to talk about Docker and Kubernetes. Then on the 13th we would talk about service mesh, and then maybe the 20th we'd be able to have the data science on. But obviously it'll be somewhat subject to when I can get interviewees available. So yeah. So hopefully y'all enjoyed this. Thanks so much to Matt Micene for coming to the show. We really appreciate it. And Chris, do you want to pitch anything else that's happening today?
Yeah, so later today we've got the OpenShift Administrator Office Hours with the one and only Andrew Sullivan. And then at noon, we're talking about AI-enabled protective management for cost and performance optimization. That is with Profit Store is the name of that company that'll be joining us for the OpenShift Commons briefing. Then after 1400 Eastern, 1900 UTC, we've got Red Hat Enterprise Linux Presents Security. So that'll be a good show to kind of finish the day, talking about the all-important thing, security. So, and then tomorrow at a very special time, 11 a.m. Eastern, 1600 UTC, we will have the one and only Matt Hicks here on the channel. So nice. Bring your questions to the head of product and technology here at Red Hat.
And that's the show is in the clouds, right?
In the clouds with Red Hat leadership, yes.
So do you know if the admin show today is going to be about storage or not? Andrew Sullivan, that's we chatted about it yesterday, but I don't know if he decided which way to go.
I mean, it can be. I think we said we were going to do storage just because of storage office hours last week.
Oh, okay. Cool.
Yeah. So there's lots of questions around storage and Kubernetes. Imagine that.
Cool. Well, thanks everybody for coming, and we'll see you next time in about 2 weeks-ish.
Yeah. Have a great break, everybody. Thank you all for joining, and we'll see you next time.